Good morning, everyone. Today I have a mission. I have to confess. I have to brainwash all of you to be a mathematician soon in future. My name is Hamideh Anjomshoa. I'm Enterprise Research Fellow at University of Melbourne. So before I start, I want to ask two questions. Raise up your hands if you believe you are good in mathematics. I'm not surprised. Second question, raise up your hands if you believe mathematics is cool and useful in your future. Great, okay. So let's see how much I can change your mind by the end of, I have 20 minutes. So first I start with my journey. I grew up in Iran. I studied there, I work in Iran, and then I moved to Australia. Moved to different cities. By the way, this is a cool map. A couple of months ago, I started to learn how to visualize with map and put stars. That's what I was exercising. So, if this is working. Yeah. So I born in Kerman. When I was in your age, that's where I was. I did my high school, and then I did my bachelor in Kerman mathematics. And then I moved to Tehran to work at United Nations for 4 years. That was it. When I was in your age, I wasn't sure how good I was in maths. The only things I knew, I enjoy mathematics, some mathematics, not everything. Yeah, I love really matrices, but geometrics, my brain didn't get them. So I was thinking, okay, as long as I'm good at one part, some part in mathematics, that would be good enough for me to pursue that one. 30 years ago, when I was in your age roughly, I also loved to code. At that time, it was Visual Basic and those big computers, but that's what I found, oh, that's interesting, and I love puzzle. That's all I knew. But I wasn't sure how good I am. So I was not impressed to see, I wasn't surprised to see that many of you think you're not good in maths. Trust me, if you enjoy puzzle, but that I'm going to show you, probably we need you more. So this is my journey from three degrees in mathematics from 3 different universities. One in Iran, Shahid Bahonar University, and the second one I did my master at Curtin University in Perth, and I received scholarship to do mathematics in University of South Australia. And it was really pleasing to see the picture of my supervisor, co-supervisor, Amy Albrecht, on that wall. That's very cool to see her picture there as well. And then I worked at 3 different places in between. The first job that I had, I was teaching Windows 95 to kindergarten students in 1995. At that time, when someone called me to say, do you want to teach kindergarten? I have to teach them how to use math, not to lick maths, just move it around. It was really cool. Again, like many of you, when I was teaching Windows 95 to kindergarten kids, when I was a bachelor student, around 19 years old, 20, I was thinking, I'm not good enough. They may figure out, and they kick me out of the kindergarten. But I keep teaching them, and I learned Windows 95 until Windows 97. And I think, okay, I know everything. I don't need to teach anymore the kindergarten kids. So remember this. If this voice coming to your mind, if you think you're not good enough, you think, switch it off. I continue until they will stop me. And then I work at United Nations. Similar story. When I joined United Nations, it was very, very scary, serious people. And I was thinking the first week when I entered the in Tehran office, working in the server room and helping people with installing antivirus, updating that, I was thinking, they will realize I'm not good enough. They will kick me out. And then in a week, I realized I'm learning a lot by working with them. How about continue working until they fire me? They didn't. I worked there for 4 years, and they didn't realize. And then I learned everything how to manage in the server room, in database, working with serious people in Geneva, different countries. And I thought, okay, that's getting boring. Now I have to move to the next stage. That's where I started thinking, let's experience working in another country or study. I chose Australia. Why did I choose Australia to study? When I was young, we were thinking with my husband, we were sitting, okay, where to go as an experience for a couple of years. 3 choices I had as an English country. As an Iranian, I didn't want to go to US because it was a kind of gambling. 50-50%, they may choose visa to Iranian, they may not. I didn't have that money to gamble on US. So I thought, okay, Canada is a good choice, UK and Australia. And then when I sat and think Canada was cold, out. UK, I look at the pictures of UK, London, crowded, rainy, I'm thinking. And then I look at Australia, cool, look at how big and green, lots of space. Why not Australia? That's all reason I had. I moved to Australia to study for 2 years. And then I received scholarship for PhD. I was thinking, how about they're paying me to study, why not? So I did PhD. And then by the end of my PhD, I had 2 kids. So I said, okay, how about I stay here? And I joined in IBM Research Australia in Melbourne when they were launching their new research center at that time. And again, IBM, I worked 10 years, and it was fun. Now I'm at University of Melbourne. When I was in Europe, did I knew I would be standing here when I'm 45? I just think as I go ahead. If some of you plan ahead or some people plan for the next 20 years, good on them. It wasn't for me. So that was my journey. Instead of showing you how to solve mathematical problem or how to modeling it, I thought that would be cool for you, what people are really using mathematics. So I'm going to show 3 different use cases that I was involved to help, and from different industry. And be ready, I'm gonna ask questions from you because we need to solve some of them together. The first problem is from my PhD work. I work with Amy and Peter and David, my other supervisors, together to schedule and design an underground mine. You see that picture? This is a big train trucks in mining. They have a very narrow tunnel, and these train trucks supposed to move underground mine, and you have to be very, very careful how to move them, go underground that tunnel. And if you dispatch them more, they will be crashing each other. In mining, they call passing bay. In trains, they call it crossing loop. To let a train pull up in that big area, let other train pass. So that's a problem that I was working on that. So how does it work? For example, in a single decline in underground mine, you see on the surface, the truck is coming down in here, and it comes further, when it goes underground mine, then we can see the other train truck has to wait until this one comes up. And they go under here, they load gold, iron, whatever they have, and they have to go back here. That's another cool picture of showing this movement as well. You know what was the question? The mining, when they were designing, the question that they had for us was, how many of these passing bay do we need for this mine? Where should we dig the tunnel? How many trucks do we need to buy and operate for this mine? That's the cool things we started to work with. Mathematical modeling. The specific area is operation research. If you're interested to know how you can solve this problem, search operation research, and they will show you what kind of modeling you need in university when you started. So let's be ready. This is one challenge that in train scheduling, in road underground mine scheduling for trucks, we have to deal with. This is very important. They call it deadlock. Whenever all trains stuck and neither of them can move, they call it deadlock. So here, tell me. These are the tracks that the trains on them. How many trains can you see here? 5, yes, great. So we have, look at these lovely, cute trains. I drove them for you 2 nights ago. So we have 5 trucks, 5 trains, trucks here. So here, which one should move next in order not to have crash? Anyone? Anyone has, yes? This is going, everyone going for, that's a good solution, but at this stage, all trains are dispatched. We cannot, imagine we cannot move backward. You see those big trains backward? So we have to be very careful. You see there is no solution for this, correct? So let's go back to once, okay, now we have the situation. Imagine we have to solve this. We have to go back one step. There are different situations we can choose. If I choose, I'll go back to your solution later. That's a good one. If I choose the red train, go back in here. Do you think if I pull a red train from T2 to T11 in previous situation, do you think we solved the problem? No. Good point. Why not? Could you say it louder for me, please?
All of the next steps would lead to deadlock.
Yeah, exactly. We haven't changed it. Look at this. I moved the red train back here. I need to learn where the laser, yes. But still, I cannot move. It wasn't a good choice. So not helpful. Let's go back again. And I love your answer. Which one was it? Perfect. So if I move this black train from T4, go back to T5 or T55, let's see what happens. And then everyone happy, now they're on the way. Now we solve the problem. They call it deadlock, and people would love to hear your inspiration to see what kind of strategy they need to implement in order this won't happen. This is one example. Clearly, whatever they are doing sometimes is not working. So we need you on the train scheduling maybe in future to help them because this is happening. Clearly, there are many reasons. This is not the only one, but the train crash happening. So we need the young brain, active like you, to help us. That was an example from train scheduling, underground mine scheduling, and you experience every day delay happening. The next is going to be, that's what's in the next industry that I'm going to show you is infectious disease modeling. The history of this work is based, before we start COVID happening, it was another infectious disease called dengue fever that was spreading around the world. And in 2017, I was working with my colleagues. That's the beauty of working in a real-world problem. You work with people from different backgrounds. Some of my colleagues were software engineers, some of them were infectious disease modeler, and I was coming from optimization background. So we worked together to see how we can control an outbreak with limited budget and resources that we have. And the other cool things, you will travel around the world to present or work with other colleagues. And that's the one that I went to Texas to present that work. So half of the world's population are at risk of contracting dengue fever. Did you know that? I didn't know either. So, and you can see the red, wherever it is more red, it means it's out of control. And Australia is still not that out of control, but it is red, it is pink. So we have to be careful. So this dengue fever spread by mosquito to human and human to mosquito. That's how it started spread. With COVID, we were not worried about that. Yeah, we didn't have mosquitoes. We already were exhausted with human to human spread. But still, we're not sure what will happen next with different variants. If with animal will be involved, we don't know yet. I don't know. We should ask infectious disease expert. I'm not. So this is a country, wherever it's more red, it means outbreak happening. And the question was how to manage, how to control an outbreak if we have few resources, if we have few vaccine. Look at this cool map. And then we start model the mathematical model. You don't need to worry about that. You can learn it later. And then from the left graph with mathematical modeling, we turn it to the right. We had more green space, but still we had red places. So that was infectious disease. My last use case that I want to show you is in healthcare, in surgery planning. Your nurses, New South Wales Public Hospital nurses, had a strike a couple of months ago over understaffing frustration, their scheduling. They were not happy, they were exhausted. So that's a problem that I was engaged with my colleague at IBM Research to work with several hospitals, like Royal Children's Hospital, Bendigo Health, to see what we can help them. Scheduling surgeries is complicated because they have limited resources, like 10 operating rooms, and they had 7,000 kids to be operated, and they were waiting a lot for their surgeries. So it was complicated. It's not something a human brain can sit and say, this is how to schedule. With mathematical modeling, we created a very efficient and simple schedule for them to see how to share their resources and which patients should be treated when. This is a nice plot from software engineers that help us to collaborate with hospitals. So I show you 3 use cases in industry, in healthcare, in industrial rail, and also infectious disease area, public health. This is not limited to this. So now I go back to my first original question. Raise up your hand if you feel better about how good you are in maths. Okay, it's working. I need to come back next year as well, please. And the second question that I had, so how many of you believes mathematics is useful and very cool to do it in future? Perfect, that's what I want to see. Thank you.